As we get into actually studying calculus, you'll find that there are two basic areas that we discover with calculus, and that is the derivative and the integral. In this chapter, we'll actually start getting into the derivative. So at the end of this lesson, you'll be able to explain what a derivative is and estimate the derivative of a graph. Before we actually dig into derivatives, before we figure out exactly what is a derivative, I'm just going to get us closer to finding what a derivative is by using a few examples. You'll look at this first example. It says to estimate the slope of the curve at the point xy. And you notice my point xy is the little star. So we want to find the slope of the curve, of this curve, at that point. Well, we found that when you want to find the slope of something, we always need 2 points, and we're basically finding the slope of a line. That's all we know how to find right now, so that's what we're going to use as the tools we already have. So if I look at that, that looks like it's the point, let's see, 1, 2, 3, 1, 2, 3, 4, 5. It's about the point 3, 5. I might be a little bit off. That's okay. I'm going to just kind of draw a line that kind of looks like it kind of goes through that curve, and then I'm going to pick this point up here. It's 0, let's see, 1, 2, 3, 4. I'll have to call that like 4. We'll call it 0, 4. Okay, so we'll just, to estimate the slope of the curve at that point, we'll estimate that line that's pretty close to that curve. So to find the slope of that line, it's just going to be 5 minus 4 over 3 minus 0. I'm just using the slope formula, and from there you'll notice I get a slope of 1/3. So it's about equal to 1/3, and I'm just going to use my approximately equal to symbols to recognize that. Okay, the next one, again, we want to estimate the slope of the curve at the point xy. Again, I'm just going to try to draw a line, because in order to get the slope right now, all we know about it is that we want to get 2 points, so we can actually find the slope of a line. That point, it looks like my star is at -1, 2, 3, 4, and up 2. So that's -4, 2. And then another point that maybe is close to it, I'm going to go up here. -1, 2, 3, 4, 5, and then 1, 2, 3. So -5, 3. So again, if I'm going to find the slope of those two lines, I'll write the slope formula for you this time, just in case you need it. But when I'm finding the slope, it doesn't matter which point is the first one and which is the second one. I'm going to let -5, 3 be my second point, so it will be 3 minus 2 over -5 minus -4. That will equal 1. And in the denominator, I get -1, so the slope of that specific curve, the estimate, is going to be about -1. Okay, so that's slope of that curve, just an estimate. Okay, similarly, if we're estimating the slope of the curve at a certain point, again, notice instead of being given a graph this time, I'm just being given a table of different points that lie on that graph. Again, if I want to find the slope of something, the only thing that I know how to do now is to find the slope if I have 2 points, so that's exactly what I'm going to use. So even though it says to find the slope at x equals 2, I can't use just 2 because that only gives me 1 point, and I need 2 points. So I could pick a point to either side of it for my second point, because again, I'm just trying to get as close as I can. So I'm going to pick the point, this point right here. So if I want to find the slope or estimate the slope of that curve, when I subtract my y values, I'll get 5.84 minus 5.00 over 2.2 minus 2.0. And then when I subtract those, I'll get 0.84 divided by 0.2. And I'm going to type that in my calculator and see what I get. 0.84 divided by 0.2. And I get a slope of 4.2. So that would be estimating the slope. Let's say I went the other way instead. I could also have picked the point 1.8 and the point 2. And let's just see how close that would have gotten me to the answer. This time I would have done 5.00 for my y2 minus 4.24 for my y1, and then 2.0 minus 1.8. That gives me, let's see, 0.76, and it's going to be over 0.2, so when I do 0.76 divided by 0.2, I get 3.8. So notice both of them are around each other, so that just estimates the slope of the curve at that point by just estimating things around it. So both of those answers would actually be right. I could also have done the 2 points, 1.8 and 2.2, because 2 is between those two. All right, so when we've been talking about the slope of the graph, we are actually talking about the slope of the tangent line of the graph, and let me just draw a picture of that. When we have something that maybe it looks like something like that, and I want to find the slope of the graph, whoops, it doesn't let me do points on here. All right, when I'm trying to find the slope of the graph at a certain point, there we go. It's at that point. Just have to do a line for that. Basically what we're doing, we're looking for the slope of the tangent line. So we really don't want the line to go through the graph in more than one spot. So we're basically finding the slope of that tangent line when we're doing this. And the slope of the tangent line to a graph is actually called the derivative. Woohoo, we're into derivatives now. All right. Okay, now what we're going to do is actually just kind of look at the derivative. So please keep in mind that the derivative is just the slopes of the tangent line. So we would like to try to draw the graph of the derivative of the function f of x equals x squared. Well, first of all, let's go ahead and draw f of x equals x squared. Now from here, what I'd like to do is to draw a graph of the derivative. So what I'm going to be doing is looking at what's happening with the tangent line. So I'm just going to draw some points, or attempt to draw some points here on my curve. I have to make lines instead, sorry. Okay, so if I'm looking at the slopes of the curve, I'm looking for the slope of this tangent line. And if you'll notice, the slope of this tangent line is negative, and it's pretty steep. So I'm going to say, I'm just making up a value here. Let's say the slope of that tangent line is about -3, right? And then if I come down to this point, and I draw the tangent line, and a tangent line is just a line that touches the graph only in one spot, just at that spot right there, never again. If I'm looking at the slope of that tangent line, it's still negative, and it's not quite as steep as this one, so I'm going to call it a slope of -2. Okay, this one down here, if I drew the tangent line, notice it's just going right straight across, and I notice that tangent line has a slope of 0. My next one, if I drew the tangent line, it was only supposed to touch once, sorry about that. This one has a positive slope, and again, it's about the same as the slope on the other side, so I'll call it a +2. And then if I come up here to this point, and I draw the tangent line, the slope of this line is also positive, and the slope, I'm going to say, since it's similar to the one on the left side, will be about a slope of 3. So if I go to graph the derivative, what I'm going to do is when I go to graph the derivative, I notice that over on the left side, let's say that over here somewhere, we have a slope that was -3, so I'm going to go actually down to -3 on my graph. And then you'll notice I had a slope that was -2 on my graph. So go to -2. I had a spot then where my slope was 0. And then over on the right side, I had a slope of 2, and then a slope of 3. So notice if I connect them, that's a picture of what the derivative looks like. So that's the derivative of that function. It's just a picture of all of the numbers that represent the slopes of the tangent line. All right, pretty abstract, so let's go ahead and try again. This one says to draw a graph of the derivative of f of x equals 4x. Well, first of all, let's draw the line y equals 4x. I know that's a line that goes through the point 0, 0, and it has a slope of 4, so it's going to look something like that. And what we would like to do is to go ahead and draw a graph of the derivative. So if I'm drawing the graph of the derivative, again, what I'm going to be doing is looking for the slopes of the tangent line. So I'm just going to pick 2 or 3 or something like that. Okay, so if I go ahead and draw the slopes of the tangent lines, you'll notice that my tangent lines have the same slope as the actual graph. So if I go to try to draw that tangent line, that line has the same slope as this line. It has a slope of 4. Okay, down here, like right in the middle, if I try to draw that tangent line, it's just headed in the same direction. The slope of that line would also be 4. If I came down here into the negative side, and I tried to draw the graph, the tangent line, and then the slope of that line would also be 4. So notice it's a consistent 4. So if I go to graph the derivative, what's going to be happening when, for all these negative values, my y value is 4. Right up in the middle, my slope, whoops, that's -4, sorry about that. Let's try that again. So it's at 4. When x is 0, my slope is 4. And when x is over here in the positives, my slope is also 4. So notice I'm getting a constant slope of 4. So that would be a picture of what my derivative looks like. So all this is I'm trying to get you to understand is what a derivative is. It's just the slope, a numerical value for the slope of the tangent line at each spot. And this just represents the slopes at all of the spots on that function. All right, the next one says refer to the graph below. Will the derivative be positive, negative, or zero at the points given? And then explain. So first thing we want to do, again, keep in mind that the derivative is just the slopes of the tangent line. So first of all, if I deal with the point A, I'm going to draw the slope of the tangent line. Okay, so it's going to look something like that. It just touches the point at one spot and it's kind of following the steepness of the graph. If I look at that, the slope of that line will be negative. So when it says will the derivative be positive, negative, or zero, the derivative on A will be negative, and then it says to explain why. The reason that it will be negative is because the slope of the tangent line is negative. I could also say the tangent line is headed in a negative direction, so the slope would be negative. You know at B, if I go ahead and draw my slope of my tangent line, whoops, I'm terrible on this pad thing. All right, so when I go to do that, you'll notice that if I'm following the slope of it, I notice that this is headed up and it has a positive slope. So at point B, the derivative, since it's just a slope, is positive. And the reason that it's positive is because the slope of the tangent line is positive. Okay, and then if we look at point C, the tangent line at point C is going to look like that. It's just a straight line across. And when I look at that, the slope of that line is 0. So the derivative at the point 0, at the point C, whoops, is 0. And the reason is because there is a horizontal tangent line. And horizontal tangent lines, horizontal lines have a slope of 0. Right, there are several ways that we're going to write the derivative. So all of these, if I ask you to do this, it's asking you actually to find the derivative. So the first way is f prime x. That's the way that it's pronounced. You'll see an f and like a little apostrophe and then an x. The other way, it might say dy dx. This is asking us to take the derivative of y with respect to x. And then the last thing that I can do is say y prime. So if you see any of those, you'll know that I'm just asking you to find the derivative. So hopefully now you know what a derivative is and how to actually find the derivative